This is the fourth and hopefully last in a series of videos in which I am rewinding this transformer. It's out of an ADM3 dumb terminal. It was wound for 115 volts, but I've rewound it for 240 volt operation. And what we're going to do in this video is a final test on it. I've refitted the copper screen. I haven't refitted the tin screen around the outside yet. I'm going to wait until I've fully tested it before I do that. But it is otherwise fully assembled. Now, I believe this transformer has been overwound in as much as the turns per volt ratio is much higher than we would normally expect. I think it's been wound as pretty much an 80 VA transformer, but it's actually about 140 VA core. And I think they did that to cut down the hum and also to reduce the magnetic field that it produces, because it is very close to the neck of the CRT in the terminal. And we noticed that in the previous video, that even though this has not yet been dipped in lacquer, which serves to kind of bond everything together and stop the parts moving relative to each other, and it quietens it down mechanically, even though that hasn't been done yet, it's almost totally silent. Can't hear it humming at all. So the setup I have here for the basic testing is we have the transformer, of course. It's powered from the mains via the PM100 power analyzer. I've got a bridge rectifier and capacitor over on the left there. You probably can't see it. And then the output of that is connected to the Kunkin KP184. Now, normally I would test all the rails together, but just to save a bit of time, I'm going to test the rails one at a time. And then what we'll do is we'll connect this to the actual ADM3 board and see if it works. So I'm starting off with the 21 volt rail. We say 21 volts, that's loaded. Unloaded, we'll see something up around sort of 27, 28 volts. And we'll then load these up to full load for each rail, for each output, and we'll see how the power factor behaves. And also how it behaves under load. Now, because it's been overwound and we've got such a high turns per volt ratio, I expect we'll get quite a bit of voltage droop on each rail as we apply load. Because there's so much copper on this, there's a lot of DC resistance, and that tends to make the transformer fairly inefficient. And you get quite a lot of voltage drop as the load increases. That's probably why the output voltages look so high. If you look at the schematic, then for example, this rail is 21 volts, even though it's only powering a 15 volt monitor, and that's 21 volts RMS AC. So when you rectify that, it's obviously much higher. Okay, we'll get this powered up. Now, we've already powered this up, of course, so we know it's not going to explode. At least we hope it isn't. But now we'll start applying a load and see what actually happens. So we've got this under load. It's set to constant resistance, 30 ohms, and the current we require for this particular rail is 500 milliamps. So I'm kind of overdriving them a little bit here just to make sure that we are on the safe side of operation. And also, of course, I'm only powering one rail at a time, so I want to put a bit more load on this just to make sure we've got a bit of overhead. As we can see, we're getting about 3/4 of an amp, and the voltage is up at 23 volts, so that's fine, no problem there. And also very promising is the power factor is 0.813, which is very good. So if we look at it in terms of VA, 28 VA, and we're using 23 watts, so that's an extremely good power factor. Okay, I'll move the connections and we'll look at the 5 volt rail. Okay, got the 5 volt rail connected. We'll power it up, and as you can see, we're getting around just over 10 volts, which is exactly the same as we got from the transformer before we started rewinding it. We'll now load it up. 9.2 volts, but we need to reduce the resistance because we need to get at least 2 amps out of this rail. Okay, so I've set that to 4 ohms. We'll power it on. 1.8 amps, 7.5 volts output, and that's fine. Power factors up at 0.847, which again is extremely good. VA24, and we're using nearly 21 watts. So it's looking good. The power factor we're getting out of this is very impressive. And now we'll move on to the first 12 volt output and see how that fares. Okay, I've got the first 12 volt rail connected. We'll power it up. 18 volts open circuit, which is pretty much what we'd expect. We'll apply a load. And I've got this set up now to give us 100 milliamps. The specification in the service manual is 16 volts at 120 milliamps. So we're pretty much bang on that. It's just over 16 volts. Power factor again is over 0.8, so extremely good. And that's looking fine. So I'll swap over and we'll look at the second of the two 12 volt rails. Okay, we're now on the second of the 12 volt outputs. Power it back up, put the load on. Okay, looking very good. Okay, it's slightly lower. There's a lot of resistance in these connections. I'm just pushing cables into the various sockets, so will vary slightly because of that, but it's still within a fraction of a volt. These were wound in parallel, so I know that's exactly the same number of turns. That's one of the advantages with using the dual output nozzles on the CNC winder. But we are going to get a bit of ambiguity here, but we're still well within the specification here, and it looks fine. Again, the power factor is up over 0.8, so I think this is a success so far, and it looks like it's safe to plug this into the actual ADM board, and we'll see how it fares and whether it can power it without any problems. Okay, I've got it plugged in. I've actually got the proper CRT connected as well. We'll give it a proper test. The multimeter is connected to one of the 5 volt rails on the board. There are actually 3 on this board. I've got it connected to the middle one, and they should all be roughly the same. The transformer is connected to the 2 power connectors. The one furthest away powers the monitor, and the one closest to us powers the 3 5 volt rails and the plus or minus 12 volt rail for the serial connection. Hopefully you can see everything. It's quite difficult getting everything into shot. Hopefully that's not being washed out with the lights. Okay, we'll get this powered up. Got the PM100 connected so we can keep an eye on the performance of the transformer and the system overall. So we'll get this powered up. Okay, we've got a beep, so that's a good sign. Now, I have been working on this board. I may post some videos on what I found, carried out a few repairs already, and looking quite promising. We're getting 4.9 volts and we're getting the cursor on the screen. Power factor is up around 0.8, which is very good, although just looking at the 5 volt rail there seemed to dip a little bit. Power factor is around 0.8. Getting more variability in the 5 volt rail than I expected. So I have been testing this using the bench supply, the 01 supplies, and found a few faults. It wouldn't, although there was a cursor, it wasn't outputting any characters on the screen. And it looks like we do have an issue here. The power factor has gone up and the 5 volt rail has dropped. So I'm going to power this off. It's not a particularly good sign. I was just saying that I have been testing this using the bench supply, and it was working fine. So either there's an issue with the monitor, because when I was doing the testing with the bench supply I wasn't powering the monitor from the supply. I was using the small handheld one that I've demonstrated recently. And it was working fine. I found a few faults. I wasn't getting any characters on the screen when keys were pressed. There was a cursor, and did a few repairs. Basically there wasn't a clock going to the UART, and the way this system is configured, it's very similar to a an ASR terminal or something like that, where you have a keyboard that outputs characters that goes out through this serial port or through the basically there's two methods of putting data out of this. You can either have a current loop or a serial port, and the data goes from the keyboard out one of the two options depending on how you have it configured. The data then comes back to memory, and then that is what is used to create the display, and it's overlaid with the cursor. So unless the system is largely working and can handle the serial data, nothing will appear on the screen other than maybe the cursor. Now I had checked, I assumed initially it was just because the terminal wasn't set up to echo characters locally, so I reconfigured it for local echo. Still didn't work, and I found there was no clock driving the serial output, so I did a bit of fault finding, found a few poor connections, and the switches that select the baud rate were also extremely dirty and weren't making proper contact. Once I got that figured out and repaired, then we started getting characters on the screen. So got an issue now where the voltage dropped to 4.4 volts on the 5 volt rail, but the power factor went up at the same time, which is kind of strange. So I'm going to power it back up. And the reason I'm feeling fairly confident to power it back up, and this, as you can see, the voltage is varying quite a bit and the power factor is now higher. We can see the voltage has dropped and the power factor has gone right up, but I suspect the current drawn, the power drawn, has actually gone down. So I assumed for a second there that we were getting a short circuit developing on the board somewhere, or that the transformer wasn't able to keep up with the power draw. Maybe I'd made a mistake somewhere winding the transformer, but I don't think that's the case. We need to do a bit more testing here. So I'm just going to get the schematic for this and show you how we're going to proceed and try and figure out what's going on. So looking at the schematic, it's extremely simple. The bit we're interested in here is at the top. We've got the 9 volt AC coming in. We've got a bridge rectifier, which is this rectifier down here. I'm not quite sure if you can quite see it. It's just next to this big capacitor, and that big capacitor is this one. And then we've got the 3 5 volt regulators, all providing 3 separate 5 volt rails. And we're actually monitoring this one, so I suspect that we've got an issue somewhere. Either the load's going up, or there's something going on somewhere in the smoothing or bridge rectifier. I don't think it's the transformer because the load is going down, it's not going up. So what I could do at this point is either connect this back to the bench supply, and when I was doing this and testing it, what I found was that the bench supply gave a steady about 1.2 amps draw, irrespective of what else was going on. And we already know that the transformer can deliver pretty much up towards 2 amps without any problems, so I don't think that the issue's there. What I'm going to do is hook a scope up to the 5 volt rail and probably also to the output of the bridge rectifier, and we'll have a look at that and see what appears to be going on, and if we can make any headway, and try and find out what's going on. It might be there's something failing on the board, but I don't think that's the case. I don't think it's the power going up, because we're seeing the incoming power actually going down, so a bit of an odd one there. Okay, I've got the scope hooked up. The yellow trace is the 5 volt rail on the board, and the blue trace is the output of the bridge rectifier. So that's this point. And we should be getting a fairly smooth DC voltage here, and of course a nice smooth DC voltage on the 5 volt rail. So we'll power this up. A bit more ripple there than I was expecting, but the 5 volt rail is holding steady this time. We're drawing about 34 watts, and that was what was odd before when it started showing this odd fault. That dropped. In fact, the ripple is increasing, and you can see it's gone up, and we've now got the same problem again. The voltage has dropped. The peak voltage is the same, but of course we're measuring the average of the yellow trace on the multimeter, and you can see that the ripple has gone up, but the incoming power has gone down from 34 watts to 31 watts. So I don't think it's something drawing excess power. I think this has got something to do with the smoothing capacitor. I've got a feeling it might be going open circuit. There is other smoothing capacitors on the board kind of downstream of the voltage regulators, and I think that's what's causing the smoothing that we're looking at, and also why we're getting this kind of 1 to 2 volt stepped value. I think that's because of the kind of reverse action of the bridge rectifier, and it's actually using these smaller capacitors on the board. So I'm going to power it off. What I'm going to try is connecting an external smoothing capacitor through some flying leads and just see if that resolves this issue. Okay, I've got a 10,000 microfarad capacitor on standby. It's not hooked up yet. I'm going to connect it to this, which is connected to the positive output of the bridge rectifier, and we'll power up the board and wait till the problem appears, and then I will clip the this is going to the positive terminal of the capacitor, negative connected through to the test leads. It's not an ideal setup, of course. We've got all these wires between the capacitor and the board, but it should at least make enough difference so we can see if it is likely that the capacitor is the problem. So I'll power it up, and already we're getting the problem appearing, and we'll wait until it fully develops. I'll clip on the capacitor, and as you can see, the voltage has gone back up to 5 volts. We're getting more ripple than we should do because this, like I say, it's not a very good way of connecting a large capacitor through all these wires, but I'll disconnect it, reconnect it. So it does seem fairly certain that this capacitor has failed, or is failing. I think it's going intermittently open circuit, so I'm going to take this off the board, replace it, and see if that resolves the issue. It doesn't look like it's a problem with the transformer, which is obviously quite a relief. I didn't want to have to rewind that, and I'll get this replaced. We'll get back on camera and see if the board behaves itself. Okay, I've removed this capacitor, and it does indeed read as open circuit, and I've got a feeling that's what's causing the problem. I don't have one with the exact same footprint, so I'll have to do a bit of searching, see if I can find something suitable. In the meantime, I've just tacked in, although it looks a lot smaller, it's actually equivalent capacity to this, just a more modern version of it. So we'll get it powered up and see if that resolves the problem. More importantly, check whether our transformer is actually properly functional. Okay, the voltage is looking good so far. Power's up slightly higher than it was, about 1/4 of a watt, but that's probably a good thing. It means we're absorbing a bit more power and getting better smoothing. And power factor is just under 0.8, which is very good. You probably can't see the screen, but it does now function. As I said, I did carry out some repairs previously, and it does appear to be working. I'm just checking for any sign of ripple or hum on the screen. It looks nice and stable. We're getting what we'd expect to see on the scope, just a bit of AC ripple on the main DC rectified line, but nice smooth 5 volts. And what we'll do now is just do a quick check to see if we're getting anything coming out of the RS232. Okay, and that's working as well, so we're getting the correct level output. I've adjusted the scope, is now on 5 volts per division, so that's exactly what we'd expect to see. We're getting plus or minus 12 volts. Nice clean signals. It's the end of line beeper, so the beeper's working as well. Okay, well that seems to be working. I'm just going to connect this back up to our 5 volt rail, and what I'll do now is leave this running for a few hours just to make sure that everything is stable. Keep an eye on the 5 volt line, make sure that it's not causing us any more problems. But the power factor is holding nice and steady this time. The DC voltage is nice and steady, and so little power coming through this, I doubt this will even get warm. All I can hear at the moment is the fan on the scope. There's no sign of any hum coming from this whatsoever. Okay, so I'll leave this running for an hour or so, and then we'll do a final check to make sure it's still working, and then we'll assume that this transformer is complete. I will put the tin shield back on before I refit it into the chassis, but in the next videos it will be back on to working on the ADM3 itself. Okay, it's had about 3 hours running and it all looks stable now. The incoming mains voltage has dropped a couple of volts since we started the test, so it has affected the power factor very slightly, but I mean marginally. Otherwise everything else is still stable, nothing is getting hot. The regulators are barely getting warm, so that's a good sign. There's nothing on the board that appears to be overheating. I have checked it with a thermal camera, and there are no hot spots or any components that seem to be suffering. The only thing that's really getting warm at all is the bridge rectifier, but it always does on these. It's one of the I think it really needs a heat sink, but they seem to survive, so it's just unfortunate it's so close to the main capacitor. So it does look like our culprit was the main smoothing cap. I may even restuff this. If you're not familiar with that, it just means taking out the innards and putting a more modern equivalent in, maybe something like the one I've got on the board, and that will at least retain the appearance. It's just using the metal case as a canister and housing to house a new capacitor. Okay, so that's it for this series of videos. We've got the transformer complete, it's behaving itself, all the outputs are nice and stable, and it is easily powering up the main board. The main board is working, but we'll look at that in a bit more detail in the ADM3 repair series.